Hello everyone. I'm going to teach you today how to name organic molecules. This is the last lesson in Unit 5. So organic chemistry is a kind of a separate branch of chemistry. It's where we focus on compounds that contain carbon. So when you hear the word organic, I know we normally think about pure or really expensive produce that has never had pesticides treated on it. But in chemistry, organic means any molecule that is made of carbon. And in addition to carbon, these molecules will also most likely contain hydrogen and a lot of times oxygen. So if you haven't already, this worksheet that I'm about to fill out, this is a note sheet. This is in your packet. It's one of the last sheets in your packet. So be filling in along as I explain all these concepts. So next to organic molecule, we're going to write made mostly of carbon, oxygen, and hydrogen. Now we're just going to dip our toes into this subject. I actually teach an entire course of organic chemistry if you're interested in taking that in the future. It's basically Chemistry 2 for advanced level students. If you liked chemistry, you want to knock out another lab science, we do a lot of labs in this course, but we mainly, like I said, we focus on molecules made of carbon. So we're going to talk about the simplest organic molecule, and that is called an alkane. Now, an alkane is a saturated hydrocarbon. What do I mean by saturated? When you hear the word saturated, you normally think about being soaking wet. Something is saturated with water. But saturated can mean that it's full of anything. In this case, we're talking about hydrocarbons, so a molecule made up of hydrogen and carbon. So what we're going to have is a carbon chain, a bunch of carbons in a line, all bonded together, and all the other bonds that those carbons can form are going to be to hydrogen. So it's a carbon chain that's fully saturated with hydrogens. And if you're thinking about in biology when you learned about saturated and unsaturated fats, it's the same concept. Saturated fats are saturated with hydrogens, meaning there are no double bonds, all single bonds between the carbons. So that's what we're going to write next. Single bonds between the carbons. And what we're going to talk about, obviously, because that's the part of the unit we're in, is how to name an alkane. So the first thing you need to do is count the carbons in that carbon chain, and then you're going to add the appropriate prefix. And that prefix is based on the number of carbons in the chain. Now, you may remember from how to name molecules, we had a list of prefixes 1 through 10. If you look over to the side, you'll notice that a lot of these prefixes are the same, with the exception of the first 4. So if you have 1 carbon, that's meth, 2 carbons is eth, 3 carbons is prop, 4 carbons is bute. All the rest of these are the same. So a little acronym that a lot of organic chemists use is Mary eats peanut butter. And that's to help you remember those first 4 prefixes that are different from the other ones you've learned. All right, so like I said, you count the number of carbons in the chain, add the appropriate prefix, and then to indicate that all of the bonds between the carbons are single bonds, you're going to add the suffix ane to the end. All right, so for this first example, we're first going to draw it. Now, using Lewis structures, the way I taught you to draw is you would draw a carbon with 4 dots to represent carbon's 4 valence electrons. And you would draw 4 hydrogens around that Hydrogen has one valence electron, so I'm going to put 1 dot, and then you would connect these. Well, in organic chemistry, this can get a little tedious because some of these carbon chains are really long. So rather than writing the hydrogen, something else you can do is just draw a carbon with 4 dashes around it, and those dashes represent hydrogen. So since this formula only has 1 carbon, we're going to use the prefix meth. And since this is an alkane, the ending is going to be methane. Methane is the gas that we use in the chemistry lab when we're doing anything with the Bunsen burners. So it's just a very simple fossil fuel. All right, number 2, this time we have 2 carbons and 6 hydrogens. So I'm going to put 6 dashes around my carbon chain. Keep in mind that carbon can only form 4 bonds. So that's why I put 3 dashes around each carbon. One of those bonds is between the 2 carbons, and the other 3 bonds are 3 hydrogens. So this has 2 carbons in the chain, so the prefix is going to be eth, ethane. All right, number 3, we have 3 carbons in the chain and 8 hydrogens. So that's 1, 2, 3. This carbon can only have 2 hydrogens because 2 of its bonds are to the other carbons. And then this carbon on the end has 3 bonds, 3 hydrogens. So a total of 8. The prefix for 3 carbons is prop. Propane is the name of this molecule. Propane is a common gas that we use when we heat our homes or we grill burgers, so you're probably familiar with propane. All right, number 4, 4 carbons in a chain. Again, these carbons on the end have 3 hydrogens. The carbons in the middle only have 2, but that's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. And the prefix for 4 carbons is butane. Butane is the type of gas that's in cigarette lighters. All right, on to number 5. We have 5 carbons in a chain. The carbons on the end have 3 hydrogens. So that's 3, 6, 7, 8, 9, 10, 11, 12. And since this is a 5 carbon molecule, we're going to call it pentane. Flip to the back. 6 carbons in a row. And that's 14 hydrogens. Prefix for 6 is hex. So this is hexane. Number 7. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 hydrogens. That is heptane. Number 8. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is octane. Number 9. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is nonane. And then lastly, 10 carbons. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And this is decane. So notice with alkanes, once again, all the bonds between the carbons are single bonds. If it was a double bond, if we had one or more double bonds between the carbons, that would be called an alkene. But we won't talk about that in this class. That's if you take organic chemistry. One more thing I want to point out is there is always twice the number of hydrogens in an alkane plus 2. So you can think of it this way. For every carbon, there are 2 hydrogens. So that's twice as many hydrogens, and then you count the 2 on each end of the chain. So twice as many hydrogens plus 2. All right, and that's all you need to know for organic chemistry for the sake of this class. And let me know if you have any questions.